until this point, we have been doing everything with right triangles. So all of this has been based off of right triangles. There is actually a relationship using trig functions, and if you take pre-cal with me, we'll actually see where this derives from. But there is a trig functions that then relate to non-right triangles. The one we are going to talk about is called the law of sines. This is actually further into the section. It's on page 610 in your books. What they found is that if you label a triangle A, B, and C, first pay attention to how it's labeled. A is the angle. The side that is opposite of the angle is side A, lowercase. B angle across from B is lowercase b, C to lowercase c. You need to know that because of how the formula is set up. What they found is there is a relationship that is created between the sine of these angles and the opposite side. They create an equivalent ratio. The sine of A divided by the side length across from it will be the same exact ratio for the sine of B divided by the side across from B and the side C divided by the side across from C in any triangle, not in necessarily a right triangle. So you can now apply some trig identities or trig theorems to non-right triangle. You cannot apply SOHCAHTOA to a non-right triangle. That is only right triangle. But this law of sines applies to any triangle. And so this helps us when we have maybe a side and an angle opposite and we're trying to solve for maybe another side. We can set up a ratio and solve the ratio. All right? So sine of A over A equals sine of B over B, which equals sine of C over C. You see that they also flipped it. With ratios, if you have equivalent fractions, you can flip both of them. So if it is easier, let's say what you need to solve for is one of the sides. Sometimes when what you need to solve for being on bottom can be confusing when you go to solve it. All right? So what you can do is you can flip them. The side over the sine equals the side over the sine. Both of those work, just depending on what you have and what you're solving for. All right? So let's look at the first example. They actually gave us an example with a word problem, but it has a picture, so we're going to do this one first. A ranger in a fire tower spots a forest fire located 53 degrees south of east. Another ranger locates 12 miles due east, reports sighting the same fire at 45 degrees. Find the distance from each fire to the tower. All right? So what they're saying is we have Ranger A over here. He sees this fire. The angle of it is 53 degrees. This ranger over here sees the same fire, but from his point of view, it is 45 degrees. And then they have told us that they are 12 miles apart. They want to know how far this fire is actually from each tower. Now, in order to do the law of sines, you must have the angle and the side opposite, okay? So that means the only side we have right now is this 12 miles. So which angle must we have in order to use law of sines? Yeah, we actually have to have C. They didn't give it to us. Can we find it? Yes, all triangles add up to 180. So the first thing we're going to do is get that angle. We're going to say 180 minus 53 and minus the 45. We're going to get that as an 82 degree angle. All right. Now we are solving for the sides. It will be easiest to flip it and say side on top, sine on bottom. All right. So we are going to say, well, 12, which is the side opposite, over the sine of 82 will equal A, that side length, over the sine of angle A, which is 53 degrees. All right? So how do we solve for side length A? What do we do to get it by itself? It's being divided by sine. So what are we going to do? Multiply. Multiply this by sine of 53. It'll cancel. Multiply this by sine of 53. All right? So in your calculator, you can do it all at one time. A is going to equal sine of 53. Your calculator should open a parentheses. Make sure you close it. Multiplied by 12 and divided by sine of 82. If you put all of that in, you will get approximately 9.7. 9.7. So Ranger A is 9.7 miles away from the fire. If we want to find Ranger B, we will do the same thing. Now, I recommend you using the side length they gave you because you rounded the other side length, okay? So since you rounded that side length, if you use that, you're going to be actually further away from the actual answer. So go back to the 12 over the sine of 82 and do the same thing for side. Oh, and I wrote it on the wrong side, by the way. Do the same thing for side B. All right, we actually solved for A. This helps to write it in the right place. So this is 9.7 miles. All right. So if we're solving for now how far away he is, we're actually going to say B, which we don't know, over sine of 45. And we're going to do the same thing. Multiply by the 45. Sine of 45 degrees times 12 divided by sine of 82. And we should get approximately 8.6. So who's closer to the fire? Ranger A or Ranger B? Who's closer to the fire? Ranger A is closer to the fire, right? And so they were able to determine how far it was from each distance using this ratio that is set up. All right. We have triangle ABC. They gave us angle C. We also have the side opposite of C, which is 14 yards. This one's going to be a little bit different. All right. So for this one, we are going to use exactly what we have. We're going to say sine of C, which is 91 degrees, divided by the side length opposite, which is 14, should equal, which angle are we solving for? Sine of B, says find B, over what's the side opposite of B? 12, all right? So how do I solve for sine B? Multiply both sides by 12. All right? Now here's the thing. If I say 12 times the sine of 91 over 14, I have solved for the sine of B. Did they ask me for the sine of B? No. What did they ask me for? The angle B. Anytime you're solving for an angle with trig, what are you going to do with your calculator to solve for the angle? You're not going to just use sine. You're going to use inverse sine, right? So now in your calculators, you're going to not use the sine button. You're going to say shift or second. And then you're going to put this in. And again, you can do it all in your calculator. Sine of 91 divided by 14. Make sure you close your parentheses. So make sure you close your parentheses.
Wait, so you don't have to do the 12 times sine of 91 14.
You have to do the inverse sine because we are solving for the angle, not the side length. All right? And when you do that, you should get approximately 59 degrees. So in this case, they want us to find the side. You want to make sure that you know which side they're talking about. So AB is this side over here. So we need to make sure that we're going to be able to use the angle opposite. They will not always give you the exact angle you need, okay? So they could have given you another angle, and you would have had to do like we did on our example, subtract from 180. But you must have the angle opposite the side, all right? So in this case, we are solving for a side. So for now, because my variable, what I'm solving for is the side, I'm going to flip those. And I'm going to say, well, I have this angle and this side. So 31 over the sine of 29 degrees should equal side AB, which I have labeled C, over the sine of 124 degrees. So when I was solving for angle, I put my angles on top and my sides on bottom. When I am solving for sides, I put my sides on top and my sine of my angle on bottom. All right? It just makes it easier when you're solving that you don't have to flip at the end. Then I multiply both sides by that sine of 124. All right? And so C should equal 31 times the sine of 124 degrees divided by the sine of 29 degrees. And so when you put that in, so make sure that when you put that in, you should get approximately 53 kilometers. All right, so make sure you get 53 when you do that in your calculator. Once you get 53, try number 4. All right, so sometimes word problems will just give you a description, like number 5. Sometimes they will give you a picture, like number 6. All right. So the first one says, a viewer is looking up at an angle of elevation of 70 degrees is the angle measured to watch a plane fly towards an airport terminal, and his distance from the plane is 2,000 meters. How far is the viewer from the terminal if the angle of elevation from the terminal is 50 degrees? So we have an airplane somewhere up here in the sky. We have someone that is looking at the airplane from some point down here, right? Some point down here. And they have said that angle of elevation from the ground is 70 degrees. All right. So my viewer has looked up at the airplane, and it took 70 degrees for them to see the airplane. All right. We'll say airplane. All right. The terminal. The terminal is over here somewhere. And that angle of elevation is only 50 degrees. And so we have an angle of elevation from the terminal that is 50 degrees. Now the distance from my person to the airplane is 2,000 meters. So which of these side lengths, if this is my airplane, which of these side lengths represents the distance from my person that is looking up at the airplane and the airplane? BC. Oh, not BC, AB, right? 2,000. BC is the distance from where? This is my person to the terminal. That is actually what they're wanting us to solve for, okay? They're wanting us to solve for this, okay? So we have a person that is looking up at the airplane, 70 degrees for them to look at it. The distance from that person to the airplane is 2,000 meters. The terminal, to see it from the terminal, is 50 degrees. They want to know how far these people are apart. So I have my 50 degrees and the side opposite, but I need the angle at the top since I am solving for this side. How do I find the angle at the top? That's the first thing I have to do. What do I need to do? What do I need to do to find this angle? Because that's the angle I need. Subtract. So I'm going to say 180 minus 70 and minus 50. What am I going to get? 60 degrees. So this angle right here is 60 degrees. Now I can solve it with the law of sines. Am I solving for a side or an angle? A side. So I'm going to put the side on top. The distance between the terminal and the person looking at the airplane over sine of the 60 should equal the distance between the person and the airplane divided by the sine of the 50 degrees. And then I can multiply both sides by that sine of 60. All right. And so again, in your calculators, you can do it all together. You can say that A should equal 2,000 times the sine of 60. Make sure you close your parentheses because it is going to open. Divided by the sine of 50. Okay. And what do you get? Yeah, you should get 2,261, I think, if you round to a whole. Rounded to the nearest tenth, it is a 0 there. So 2,261 meters. All right. So go ahead and try number 6. They did give you a picture. Go ahead and try number 6.